Hey there, welcome to this summarized tutorial. My name is Miracle Charles Ebumbu and I'll be your computer studies tutor. So let's jump right into it. The first topic we're going to look at is the history of computer or history of computing. And also, before we go into the actual history of computing, we have to look at the definition of a computer. It would be bad to go into the history without actually knowing what the definition of the actual thing you're going to its history and what for. So I have two definitions. The first definition of a computer is that a computer is an electronic device that processes data according to a set of instructions called program to perform various tasks. And the second definition actually would be a computer is a programmable machine that can store, retrieve, and process data to produce meaningful outputs. The first definition is pretty basic. That's actually the definition used almost everywhere. But the second definition is more broad. It's something you would use even in the university, anywhere you go. It expresses more of the programming part of a computer. Most developers call this particular definition their own specific definition, but it's actually better than the first one, but it depends on who you are speaking to or who you're trying to define a computer to. But both of the definitions are okay. So that's actually the definition. Assuming you wanted to define a computer, now you know. That's the definition. Those are the short definition, the shortest way of defining what a computer actually is. So now we'll be moving into the history or the actual history of computing. And there are two histories. We have the 19th centuries and we also have the 20th century. So the 19th century is the kinds of things that passed as computers up until 20th century, which brought about the major boosts in technology that brings about the computers we can actually use these days. So in the 19th century, before electronic computers, humans and mostly women manually performed complex calculations for scientific and engineering projects. This was for big companies, even for government parastatals. So the term computer initially referred to mathematicians and astronomers who perform calculations. And remember, most of these astronomers and mathematicians were females, women to be precise. So the first 19th century computer we're going to look at is the abacus. The abacus was an ancient calculator which consisted of rods with beads, not the beads you wear on your neck. Literally, they were like boxes that had rods going across from one side to the other with beads on it, which each of these beads were arranged in place value systems. So the users would manipulate the beads to perform some basic arithmetic operations. When we're talking about the manipulations, it wasn't as if you just have to randomly move it. Based on the kind of arithmetic operation you were trying to do, it would be easy. You slide it to one side or to the other side, or most often to multiple sides, either to the left or to the right, which depending on the kind of calculations which you are trying to do. So with practice and skill, you need to practice how to use the abacus. It wasn't something that anybody could just basically start using it and get used to using it. You had to practice how to use it. And then you had to also be quick with it and also be accurate at the same time. So that was how the abacus was in the past. So the next thing we're going to be looking at is the slide rule. So the slide rule was more of a mechanical analog computer, which was used by scientists and engineers. Picturing a slide rule is like having two modern day rulers which slide towards the opposite side of each other. That's actually how the slide rule was. And it had some engravings that had some values. Similar to the way the place value system was on the abacus, the slide rule had something that's similar. But in this case, imagine having a ruler which slided on the opposite end, towards the opposite ends rather. The slide rule was used in that particular manner for arithmetic operations, even some scientific kind of calculations that the engineers and scientists use. So that's about the slide rule. So the next thing we have is Napier bones. Napier's bones was invented by a Scottish mathematician called John Napier. So what did the Napier bones actually help in doing? Napier bone aided in doing some multiplications. So the Napier bones were not actually bones. They were just wooden structures, or in most cases, metallic structures, which had some engraved kind of like a ruler. Imagine a ruler, but in this case, in the shape of a rod, which has most of the number bases and most of the numbers, which was used for calculations. That's actually what the Napier bones was like. And it was used mostly to find the product for multiplications. It was mostly used for multiplication. So imagine having rods that had digits engraved on them, and then they were used for multiplication mostly. Not as if that it wasn't possible to use it for other things, but it was better for multiplications based on the way it was designed. And you have to remember that the person who did this was a Scottish mathematician named John Napier. Next, we have the Pascal calculator, or we can call it Pascaline. So the Pascaline was actually invented by Blaise Pascal, and it was invented in the year not exactly the year, because the exact year wasn't given. It was given like a range of years. So it was invented in the 1940s. The first mechanical calculator for addition and subtraction. Remember, Napier bones was more specialized for doing mostly multiplication. But in this case, Pascaline was the first mechanical calculator for addition and subtraction. So it had gears and wheels and dials that represented digits, akin to the mechanical odometer. That's basically what the Pascaline was actually like. And it was invented in 1640s. The Pascaline calculator was specifically specialized in doing addition and subtraction. This is actually, it's being able to do two things at the same time, whereas the Napier bones was mostly used for multiplication. So we have the Leibniz multiplier. So Gottfried Wilhelm von Leibniz, which saw how the Pascaline was and decided to improve on it. So the Pascaline, it was expanded on when it had to do with addition and also the subtraction, introducing multiplication through a sophisticated gear system. So imagine the Pascaline, it had just the ability of doing two things, but it was doing addition and was also doing subtraction. So in this case, Leibniz multiplier is actually an improvement on the Pascaline. But in this case, it was given the ability to do addition, subtraction, which naturally the Pascaline was able to do. But multiplication was introduced through the use of sophisticated gear system, which made it easy for it to do not just the addition and subtraction, but it was able to do the sophisticated multiplication, because to do the subtraction and then the addition was easier when you had to do with working with the Pascaline, but you would not be able to do anything that has any relative need for multiplication. So that's where the Leibniz multiplier actually improved on the Pascaline. Next, we have Jacquard loom. So the person responsible for Jacquard loom is Joseph Marie Jacquard. So you know where the Jacquard comes from, not the loom actually. So the Jacquard loom was invented in 1800s. When I say 1800s, I'm talking about 18 with 2 zeros after it. So more like 2000s, but in this case it was the 1800s. So the Jacquard loom used what we call punch cards. These punch cards that we're talking about here were like having an actual card that had holes in them at specific positions. So this was the first technology that was mechanical, which was programmable. It had the ability to be programmed. Programmed in this case means that you can actually lay a specific set of instructions prior to the period which those instructions are going to be followed to solve a particular problem. So it marked the milestone in machine technology. So this was the first programmable device, and it was invented by Joseph Marie Jacquard in 1900s. Now we have Charles Babbage analytical machine. Most people call it engine. Most people call it machine. So wherever you see machine or analytical machine or analytical engine, it's still the same thing they're talking about. So a lot of people refer to Charles Babbage as the father of modern computer. So the analytical engine was conceived in the 19th century, to be precise. It aimed to be a versatile mechanical computer, which in this case was more advanced than even the Jacquard loom that was programmable. So it included features like conditional branching, where conditional branching is a situation where you are, let's say in programming, is where you actually program something. Let's say you choose that if it rains today, I am going to use an umbrella to go to school. So in the case where there is no rain, it means that you are not going to use an umbrella. That's conditional branching, taking certain decisions based on a particular condition's outcome. So if this is true, then this happens. If this is false, then that happens. That's basically how the analytical engine was. And that's, moreover, the main reason why Charles Babbage is coined the father of modern computers, although what he did was in the 19th centuries, not in the modern era. But this engine was very, very smart, although he wasn't able to complete the architecture of the analytical engine. So we have the Hellerith census machine. So a certain person, yes, we can say that, Hermann Hellerith. Now you know where the Hellerith census machine came from, where the Hellerith in particular came from. So Hermann Hellerith created the Hellerith census machine in the 19th century, and it was used for data processing, specifically for the census in US in 1890, actually. So the machine was actually using these punch cards that, you remember, the first time we heard about the punch card was Jacquard, where it uses programmable punch cards which could follow specific instructions. And in this case, Hellerith actually made a difference to it. He was able to make the Hellerith census machine to be able to encode information based on census. So it was able to collect information and then use this information to program the results of the information it's collecting, the data it was collecting, into information that was reusable. So this is actually what set Hellerith's census machine apart. But as the name implies, census machine, it was mostly used for census, not for the normal multiplication and subtraction that you may think of. So we have Burroughs machine. This is one machine in the 19th century or earlier that was not developed by a specific individual. Rather, this was developed by a company called the Burroughs Corporation in US. So later it was called the Unisys. That's Unisys is the UNISYS. So it made contributions to business specifically. This was more of a business-centric machine. It wasn't for the everyday person who wants to do calculations, like doing the subtraction, division. Not that it wasn't able to do these things, but it wasn't for individuals to use. It was mostly for companies who wanted to do things like bookkeeping, record keeping, and also to automate tasks like calculations. You don't want someone to specifically sit down and do the calculations. Rather, you needed a machine that could just automatically do all these calculations on its own. That was what the Burroughs machine was actually made for. It wasn't made for individuals. So that's it for the machines, or the seemingly computers that were created in the 19th century. So we're going into the 20th century, and the first device we're going to look at is ENIAC. And it was called as a device that was pioneering electronic brains. So you may ask, what does ENIAC mean? ENIAC means Electronic Numerical Integrator and Computer. That was the full meaning of the ENIAC, quite long. So the founders of this machine were J. Perspe Eckert, an engineer. He was an engineer. So he also had help from a man called John Macaulay, who was a mathematician and also a physicist. So the contributions of the ENIAC was actually that it was the first general purpose electronic computer. Remember, if you look closely back at the previous generations of computers, that's the 19th century, they were only able to do one thing at a time. But the ENIAC brought about the era where computers could do multiple things and was faster than the previous computers and was also more efficient, as well as the fact that it was programmable. Not just programmable, it was reprogrammable. So it was a machine that you could program it to do a particular thing, and then you have the need for it to do something else, and then you reprogram it to do another thing. So the ENIAC is one of the pioneering devices that paved the way for modern computers. Next device we're going to be looking at is EDVAC. And the EDVAC was the device that was used for building the future of computers. So you may ask, what's the meaning of EDVAC? You have all these new computers and then their weird name. So in this case, the EDVAC was like the full meaning for the EDVAC was, and still is, it's not as if it has changed actually. So it's defined as not actually the definition. So you don't go to call that the definition. So the full meaning of EDVAC is Electronic Discrete Variable Automatic Computer. That's the name. Very long, we know, but we have to go by it. So the founder is actually John von Neumann, who was a mathematician. And he's the one that founded the concept, not actually the one that made the machine itself. So what were the contributions that EDVAC was able to do? The EDVAC was able to store programs. Now, this was the first time that machines or a computer was able to store the program. Most of the programmability of the previous computers was that you can program them, but the thing is you cannot store what you have programmed. You have to bring back that same program you created the first time and insert it into the machine to allow the machine to be able to do what it's supposed to do. But in this case, the EDVAC was able to overcome that by being able to store the programs and then reuse these programs that were given to it. So the next machine we're going to be looking at is UNIVAC. And UNIVAC was the first commercial success story. So in this case, it wasn't just a general purpose device, it was commercially available. That means it was available to almost anybody who could afford it. So you may ask, what's the full meaning of UNIVAC? Full meaning of UNIVAC is Universal Automatic Computer. That's how short it was. And now the founders, the people who were in charge of this, are the same people who built the ENIAC. They realized that there was need to improve on this machine that they were working on. So the founders are J. Persby Eckert, and we also have the John Macaulay. So same people who worked on the ENIAC. So what was the contribution of the UNIVAC? The contribution is actually that it was a universally automatic computer and was the first commercially available computer. The reason why we're saying commercially was that most of these other machines were just owned by companies or government parastatals who used them for specific things. It wasn't something that was readily available that you can get anywhere. But the UNIVAC was the first success story of doing that. So basically, we've come to the end of this particular topic. That's the history of computer. We've looked at the history of computer. We've looked at the definitions of computer, where we saw the generations of computer. In this case, we'll say the 19th century computers and also the 20th century computers. So we looked at that, which is part of the history of computers. We looked at the two viable definitions of a computer. So we also looked at the 19th century computers, back to that, which in the 19th century computers, we looked at the abacus, the slide rule, Napier-Bones, Pascaline, Leibniz multiplier, Jacquard-Loom, the analytical engine, and we also looked at the Burroughs machine. Remember, the analytical engine was invented by Charles Babbage. We also looked at the 20th century computers, which we have the ENIAC, the EDVAC, and the UNIVAC. I hope you remember the definitions of both of them. Thanks for watching.